So here's our introduction to balancing equations. So one of the fundamental ideas of science is the law of conservation of mass, that matter is neither created nor destroyed. So like on this, if you put in two nitrogen atoms, two had better come out. Now they might rearrange, of course, because that's a chemical reaction. Of course, they're probably going to rearrange. If they didn't rearrange, we wouldn't even be talking about it, because we don't have discussions about, and then nothing happened. I mean, what's the point, right? So we only talk about this, things where it did change. So yeah, these might change. They will change from left to right, but they don't disappear and they don't appear out of nowhere. So I want to pretend that we don't know the coefficients, the numbers in front, and let's try this. Also here, coefficients, if you need to write that down, take a note. The coefficient is the big number in front. I would make a note if I were you, because I had a kid already today who got a little lost and forgot what that word means. The coefficients are the numbers in front. And remember also there's an invisible one here. No number is one, blank is one. And so the coefficient here is 3, and the coefficient here is 2. Oops. So let's pretend we don't know that, and let's see how we could generate the coefficients here. Now, in the future, later on, we'll come to some problems where I'm asking you what the products are, but honestly, not for this kind of reaction. I'd be a little stuck to myself. So I'm telling you, it makes NF3. Let's just say that we know it makes NF3 because somebody discovered that. Okay. However, without the coefficients, this is a lie, because it's not possible, because you can't put in two N atoms and then have it react, it changes and becomes something with only one N atom. And then some kid says, but, oh, it just left. It didn't become one atom, it just left. Okay, but if something gets created that leaves, we still write it down. We don't just skip it. And for instance, a lot of times you'll see later on, we make stuff that has CO2 in it, which is a gas. That G means gas, and it escapes and it runs away into the atmosphere. Sure, it escaped, and you don't find it, in your beaker or something. Sure, but we still write it down. We don't just skip it and pretend it never happened. Also, you might recognize that if you're using the periodic table that I put up, then it has a star in the N and the F box, which means if you put a bunch of N's together with their own kind, they tend to make pairs. That's diatomic. Di means two. It's diatomic. It's two atomic, two atoms. So N tends to make pairs, doubles here, and so does F. So this is the way that they exist when they're on their own. And we're just telling you it makes NF3 because we discovered it. So just believe us, honestly. But if that's true, then there must be some ratio that this works in that doesn't end up being a scientific lie. So one of the things that I notice is, and this is going to come up a lot, like 100 more times. So, you might write down a note. I have my classic 2-3 problem. I have 2 of this on one side and 3 on the other. And it goes back kind of to if you had, like 6th grade fractions, you had 1/3 plus 1/2, and they tell you, oh, you can make lowest common denominator. And you probably spent a week making lowest common denominators. And the lowest common denominator here would be 6, because 2 and 3 meet for the first time on the number line at 6. So let's make there be 6 of these, 6 F's on the left and 6 on the right. And that means I need 3 sets of this and 2 sets of that. And when I say that, by the way, in case you want to write this down, in case this helps, what I mean is there's 2 of this. So that means I have 2 N's and 6 F's. So this 2X is a multiplier through. Because occasionally, some years I get a kid saying, but it's no, it's 5. 2 plus 3 is 5. So it multiplies through. So now I have two n's and 6 f's. And then one of the fundamental principles here is you're going to fix something and then just keep fixing, just keep fixing, just keep fixing, as we'll see down here. Although sometimes it turns out you fix something by accident. So when I put it to here, I got 6 f's and 6 f's. And now let's double check the nitrogens. Do I need to fix those? I have 2 n's, and look, I have 2 n's. So the left side has 2 nitrogen atoms. That now they did get rearranged, but there's still 2 nitrogen atoms existing. And I had 6 fluorine atoms on the left and then 6 still on the right. And it just occurs to me, this might be one of those topics that some people already have a head start on, because some of those ambitious 8th grade teachers get into this. Just asking, just because I feel like asking. Anybody already saying, oh yeah, I've seen this?
Yeah, I've already seen this.
Yeah. Okay, so however, I want to make a point, because I have learned to like do the wrong thing and show that it's wrong. Okay, let's pretend I didn't do this yet, just for a minute. You don't have to erase anything. What I get though is kids saying, oh, he made this big point about you gotta have 2 on the, if you got 2 on the left, you gotta have 2 on the right. Okay, you want 2 on the right? And this is wrong. This is really wrong. I'm telling you it's N1F3, but a kid goes, you want 2 on the right? Sure, there you go, 2 on the right. Got it done for the N, right? And then if they're really, really off base and they really don't get it, then maybe they even do this. Oh, 3? Nah, 2. Look, I solved it. No, because this is the lie now. This is not what nature made. It doesn't make a combination of 2 N's and 2 F's. It makes a combination, because we're telling you, because we researched it. We went to a lot of trouble and we found out it makes 1 N combined with 3 F's. So if they tell you what the formula is of the molecule, you don't get to just go play with it, because that's not what nature made. That's like saying, and then it makes carbon dioxide, and some kids pretend, and then some kid says, oh, that doesn't balance for me. I'm just going to call it CO3. There, I balanced it. Whoa, buddy, that's not true. It doesn't make that. That molecule is a lie now, because that's not how that works. So we can't just go changing the molecules because we feel like it. Although next week, I think maybe we'll get to reactions where I say, okay, I'm not telling you the product and you have to go make it. In which case we got to go back to that whole thing. Remember about ionic formulas? And if it's +2 and -1, then I got to have 2 of that. In that case, you're inventing it. You're not just rewriting it. You're not just cheating. You're actually writing it the way it would be. Okay, but if I'm telling you that this is what it makes, we don't get to go screwing around with the subscripts, the bottom numbers, sub, under, script writing, the under writings. So I'll put this back in here. Okay, now that was kind of a lot. So is there somebody who is thinking, that guy talked a while, but there's still this thing I don't get about something that this made you think of? Or like, I got an idea, or I didn't know what you meant by that thing, or can I do this? Well, how about we try number 1? Now, I like this box method, but it is a little simplistic, and it's okay to get hand-holding at the beginning. Everybody needs to start at the beginning. I'm just saying that we don't usually use the boxes in the future. I mean, I don't care. I don't care how you get the right answer, right? If you need to make a box, go right ahead, sure. I'm just saying, I bet you get to the point where you don't want to do the box because it's too much trouble, because you can do it in your head. So I'm not saying this is how we do it, we make boxes. I'm saying maybe this helps us get started. So how many H's are on the left in the reactants right now? 2. How many O's are on the left of the arrow? 2. How many H's are on the right? 2. How many O's are on the right? 1. Well, this can't be true because you can't put in 2 oxygens and get out 1. You destroyed oxygen atoms. And if you destroyed a billion of those, you've basically sort of invented an atomic bomb and you blew up your whole city and a lot more probably. And of course, that didn't happen. That's not true. That can't be true. So what we need to do is make these numbers match, and all we can do is multiply. So how about we take the thing that has 1 oxygen and we multiply it by 2, and then we have 2 there. Now, what happens in this one is what's more typical. This one was extra simple because we didn't have this extra little sort of problem. When I did that, I messed up this number. This is no longer 2. Now I have 2 sets of 2 is 4. So that's pretty typical. You fix one thing, but it messes up something else, which means you got to go fix that one. And sometimes that messes up something, so you got to go fix something else. Just keep chasing it. Just keep working and fixing and working and fixing. And if you're doing it right, all of a sudden it'll just get fixed. So let's see if we can leave the oxygens alone because they already match. Let's try to change just the hydrogens. Well, I can change just hydrogens on the left. And I can put a 2 here, and 2 sets of 2 is 4. And now we could double check. 4 hydrogens go in, 4 hydrogens come out. But remember, that's a 1. 2 oxygens go in, 2 oxygens come out. There we go. Yeah, that's something I can buy into. I talked over you. Sorry. I'm going to shut up. What?
So O2 is 1?
A blank in front means 1, yeah.
Oh, okay.
Because you know what? I'm glad you said that, sort of, because occasionally I have a kid say, no, that's a nothing, and nothing is 0. And I go, really? You think we're going to write down everything we don't have? Why don't we spend all week and write down everything we don't have? That sounds like a waste of time. Do you know what I mean?
Yeah. So do you mind if I write a 1 in front of them?
Nah. Go ahead. I bet by next week you start skipping it, but sure.
Well, I just like it because it kind of like helps my brain understand.
Okay. I don't argue with right answers. Good point. Questions are good. Anything else on number 1? Or it makes me think of this thing? Questions? Sure. Well, on number 2, let's count. We have 4 phosphorus and 2 oxygen. And then we have 2 phosphorus and 3 oxygen. And this sets up my classic even odd problem. Even odd. This number is even, this number is odd, and they got to match. Now, I don't know if anybody has said this directly to you before, because there are things that the math teachers would say, oh, they know that. And I come back and say, no, they don't, because I asked them. You think you said it, but they missed it. Or somebody said it in 6th grade and you forgot by now. But if you have an even number, can an even number multiply to be odd?
Depends on what number it is. But
No, it can never.
An even number cannot multiply to be odd. And Ty, just in a nice way, what did you mean it depends on which number? Just to be helpful.
I mean, I thought like if you used like a different said number, it would somehow at least 1 point being odd.
No, because, okay, let's think of what 2 means. 2 means like 2 blocks, right?
Yes.
And so if I multiply this, I get another 2 and another 2 and another 2 and another 2, and it's never an odd number, is it?
No.
You see what I mean?
Got it. Yeah.
So, and maybe you've got to write this down, but if you have the even odd problem, even number, odd number, you have to arrive at an even number. So what we need to do is change the odd one to an even number. And you might need to want to write that down. If you have even and odd and you got to make a match, so I call it our even odd problem, even if it goes odd, even, whatever. Even odd just sounds better. You have to arrive at an even answer. So I have 2 and 3. I need to arrive at an even number. And the first number that will work is 6, like we were talking back on the first part. So how about we do this? Let's have 2 of this, which makes 6 O's, and 3 of this, which makes 6 O's. Now, also, this lets me introduce another little concept. Sometimes you fixed something by accident. And you may not recognize it yet, but I fixed my phosphorus by accident because this is now 2 sets of 2, and that isn't 2 there. So it's 4. And I fixed it without even thinking about it. I fixed it by accident. That's a very good sign. That's very common. I can't say it happens it kind of happens all the time. And I don't mean literally every time, but in any set of 10 problems, it probably happens like 6 times or something that you fix something by accident. And then you're probably done. That's a very good sign. You're probably right and you're probably done. Just double check everything. 4 P's go in, 4 P's come out, 3 O's go, or 6 O's go in, 6 O's come out. Did I repeat something on number 2 or it makes you think of something? I'm going to say in the world's least consequential quiz, try number 3. You don't have to tell me if if your paper bursts into flame because you did it so wrong, you don't have to tell me. Just take a crack at it. And then maybe it prompts a question. So I have 2 N's on the left, 2 on the H's on the left, 1 N on the right, 3 H's on the right, which sets up my classic even odd problem. And that's probably where I would start personally. And you might take a note. I would fix the odd numbers first or the small numbers. If you got something really a lot smaller, I'd start there. Or if you have something odd, I'd start there. So the even odd problem and the 2-3 problem is the most common kind. These got to meet at 6 then. So let's have a 3 here, and that makes 6 of that, and a 2 here, and that makes 6 of that. Now, that also changes something because I now have 2 n's, and that means I fixed my nitrogen by accident, which is a good thing. Anything on that? Well, how about we try number 5, and maybe we can speed up a little bit like we did on 3. That's 1 of these and 4 of that and 2 of that. And 1 and 2 and 4. Well, which one should we fix first? I don't know. Pick something. Honestly, there's probably no preference. It probably is just as hard one way as the other, or just as easy. So let's pick something. BR, just because, I don't know. So this is 4 and that's 2. So I'll multiply this one by 2, and that gives me 4. And this is 4 and that's 2. So how about I multiply that by 2, and that's 4, and everything's done. Now I want to show you something on 7 and 9 though that I don't really agree with the way this, I don't remember. I bought this online from somebody selling materials. Anyway, he, she made it, whoever it is. Let's not count the N and the O separate. See how the NO3 is still NO3 and it didn't change to NO2 or NO5 or something. So let's not do this. It's harder that way. Let's talk about it as a group of NO3s. It's going to speed things up. So then I have 1, that's silver, by the way, and it doesn't make sense in English because people have been using silver since, like, I don't even know, 5,000 years ago or something. So it comes from the Latin. Anyway, and 1 set of NO3 and 1 copper. And copper also has been used since, like, geez, again, 5,000 plus or something years. So again, it's from the Latin. On the right side, I have 1 silver and 2. Now let's make sure we know that. I'm pointing, you're looking, that's 2 sets of NO3. There are 2 NO3 sets and 1 copper. So obviously the place to start is fixing the NO3s. So let's put a 2 here. And that means I have 2 sets of the NO3s. But that also means I have 2 silvers. But that's easily fixable because I can put a 2 here. And everything balances. Is there something I should go back over, or it makes me think of something? This is one
Are
way.
we
Yeah.
know if reactions endogonic or exogonic yet?
Boy, I missed that. Can you say that again?
Are we supposed to know if a reaction's exogonic or endogonic yet?
I heard Are you saying exothermic? What's the word?
Exogonic and endogonic, like releasing energy and needing
Alright.
energy.
I think you stumped me on a vocab word there, buddy. Exogonic, huh? Exergonic. Releases free energy. That's a term that doesn't even come up in the AP class. So you beat me on that one. Where did you learn that?
Last year, when I was in AP Bio, there was some chemical reactions, so we had to know if it released energy or not.
Actually, in the AP class, we get into that idea, but I just didn't recall that term. But no, that's not going to be, not that later on. I mean, if we can get through as much this year as I usually get through, at the very end, I end up saying stuff like this. And this is off the the topic at the moment, everybody else. But if I say the change in heat is, and let's just make up a number, negative 100 kilojoules per mole. That means if you run this equation a mole of times, which is like a billion times, actually it kind of is. Anyway, it's in that neighborhood. Then you would get 100 kilojoules coming out. Negative means they came out of the chemicals. So then you would say, oh, the heat is a product. But that's like early May or late April kind of thing.
So wait, when energy is lost as heat, can it ever be recovered?
When energy is lost as heat, what?
Can it be recovered?
Not all of it. That's the what is it? Is a second? I forget. Law of thermodynamics that heat created can never entirely be recovered, which is why you can't have a perpetual motion machine. Any work that gets done creates a little bit of heat, at least a little bit, and you can never recover 100%, which means that the amount of available energy in the universe is always going down. It's been going down since the Big Bang, and it's only getting worse. Which is why there's a phrase, the heat death of the universe, that at some theoretical point, there would be no more available energy to do anything more in work.
Does this apply to things like magnets and gravity as well?
No.
All right.
I don't mind talking about it with you more later if you want, but I think right at the moment I'm going to go on tonight. So I'm going to pull the same trick and say having P and O and 8O and H together are a pain because look, PO4 doesn't change. So how about we just call this PO4? It's going to speed things up. And I want to look, OH doesn't change. So I want to call this OH. Then I have 3 NAs, sodiums. I have 1 set of PO4. I have 1 K and 1 OH. On the right side, I have 1 Na, 1 PO4, 3 Ks, and 1 OH. So you can pick something to start with. It probably doesn't matter. You can either pick the Na or the K to fix first. I don't know. Na, just because. How about I take the 3 there, and I'm going to multiply this one by 3. However, that changes, okay, that changes this, what did I say? Oh, that changes this to a 3, which is what I wanted. Notice, though, that it also changes the OH to a 3. Now I have 2 things that don't match, but look, they're together. The KOH is together. And if I put a 3 here, this is what I meant by fixing stuff by accident. If I say, oh, I'll fix the OH and I'll put a 3 there, that fixes that one to 3, and it also fixes the K to 3. So I fixed the K by accident, which is good. It's a very good sign. You're probably right, and you're probably done. Just go double check. But it is. So that's been my intro bit, and it's been about half an hour. So is there anything on any of this that I should repeat or, you know, answer it? It makes me think of this thing, or what if that? Even that kind of question is okay. And I just saw the chat. Sorry, the chat does not go ding, and I was staring at the paper that whole time. Can I just say, turn the even and odd number into the common denominator? Somebody chats. If you want to think about it that way for a while, that's fine. My only picky point is that when we say we have the even odd problem for H here, it's not a denominator is all. I mean, to be really picky, that's just not, it's not the bottom of a fraction, so it's not a denominator, but to be more picky, it would be, we're finding the common multiple. What's a multiple of 2 that is also a multiple of 3? And the answer is 6. 6 is a multiple of 3 and 2. So I don't know if that person wants to speak up, or I'm looking at the chat. Also, if you have further questions, you can hang back for a moment, but I'm going to create breakout rooms and say, go do the simulation and help each other out, by the way.